Welcome to Top Acad. In this series, we're going to learn about the binomial theorem. But before that, let's understand what does a binomial mean. Okay, so if we have an expression in the form of a plus b, this is called a binomial because it has two terms. This is term 1 and term 2. In binomial, bi means 2. So binomial is an expression with two terms. And if you have anything like a plus b to the power n is called the power of binomial. Okay, so now we know what a binomial is, and most of you will know what is a plus b whole square, right? It is simple: a square plus 2ab plus b square. And if I say a plus b whole cube, then a few of you might know this. It is a cube plus 3a square b plus 3ab square plus b cube. If you don't know that, you can even do a plus b into a plus b whole square. Okay, and now if I ask you what is a plus b whole to the power 4, is it easy to find a plus b to the whole to the power 4? Not really, and many people might not memorize this, and there is no need to memorize this. We can still do it. We can either do a plus b whole square or a into a plus b whole square, or we can also do a plus b. Now that we know a plus b whole cube, we can do a plus b into a plus b whole cube. But we can imagine like it's gonna be quite cumbersome to calculate this. Is there a simple way to do it? Yes, we can do it. Let's see a pattern here. So in a plus b whole square, you have the first term and the last term is a square and b square, right? In a plus b whole cube, the first term and the last term is a cube and b cube. And similarly, in a plus b whole to the power 4, we can write first and last term will be a to the power 4 and b to the power 4. Okay, first and last term is easy, but how do we find the middle terms? Okay, again I see a pattern here. What is the pattern? If you observe, the power of a keeps decreasing by 1. This is a to the power 1 until it becomes a to the power 0. You know, a to the power 0 is 1. That's why we don't have to write it here. Okay, so let's do that here. We can now figure out what is the value of a in each term. A cube, a square, and a to the power 1. What about b? If we observe here, the value of b, the power of b increases by 1 until it becomes b to the power 3 for a plus b whole to the power 3. In this a plus b whole to the power 4, we can say that it starts from b to the power 0, it becomes b to the power 1, b square, b cube, and finally b to the power 4. But what about these coefficients? 3 and 3. How do we find the coefficients here? For this, we have something called a Pascal triangle. Let me show what that is. So, in Pascal triangle, if we have something like a plus b to the power 1, which is nothing but a plus b, we take these coefficients and write 1 and 1 because the coefficients here are 1 and 1. And now let's see a plus b whole square. It is a square plus 2ab plus b square. So the coefficients are 1, 2 and 1. And for a plus b whole cube, it is a cube plus 3a square b plus 3ab square plus b cube. This will be 1, 3, 3, 1. Now, if you see a pattern, every row starts with a 1 and ends with 1, right? And there is a beautiful pattern here. If you see if you do 1 plus 1, it is 2. If you do 1 plus 2, you get 3. 2 plus 1 again is 3. So can we find the next row? This is row 1, row 2, row 3, which corresponds to a plus b to the power 3. Row 4 will be 1. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and it ends with 1. Also notice that if the power of binomial is 1, there are two terms. If the power of binomial is 2, there are 3 terms, 1, 2 and 3. If the power of binomial is 3, there are 4 terms. Okay, let's now do a plus b to the power 4. It's 4, 6, 4 is the coefficient of the middle terms. Let's go back and now we can write 4, 6 and 4. Isn't it simple? So we can easily find a plus b whole to the power 4 without even using multiplication or anything else, which can be quite complicated. So now we can easily find a plus b to the power 4. And do you think you can do a plus b to the power 5? So it will be 5th row in the Pascal's triangle. You know, it starts with 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. And 5 and 1. Okay, so now we can write it is a to the power 5 and b to the power 0, because you know b to the power 0 is nothing but 1. I'm just writing it so that you know that it always starts from 0 here. And write the coefficient here, 5, a to the power 4, b to the power 1, plus take this coefficient 10, a to the power a cube, b square, and 10 a square, b cube, plus 5a b to the power 4, plus you can say a to the power 4 into b to the power 5. Again, a to the power 0 is equal to 1. And there is one more beautiful observation that we can make. We are doing it correctly. If you add the powers of the binomial, it is always 5. Let's do one simple problem using the binomial expansion. Okay. So it says expand and simplify 2x plus 3 whole to the power 4. Okay, we know the first row has 1, 1 in Pascal triangle. 1, 2, 1 is second row. Row 1, row 2, row 3, we need row 4. 1, 3, 3, 1, 1, 4, 6, 4, 1. Okay, here, so we know that a plus b whole to the power 4 is in the form of a to the power 4 plus 4 into a cube b to the power 1 plus 6 into a square b square plus 4 into a to the power 1 b cube plus b to the power 4. Okay, now here a is equal to 2x and b is equal to 3. Let's plug in these values here. 2x plus 3 whole to the power 4 will become 2x whole to the power 4 plus 4 into 2x whole cube into 3 plus 6 into 2x square into 3 square plus 4 into 2x 3 cube plus 3 to the power 4. Okay, and now if we expand this, 2 to the power 4 is nothing but 16, x to the power 4 plus 2 to the power 3 is 8, 8 into 12, 96, x cube plus this is 4 into 6 into 9, right? So this is 24 into 9, 9 4s are 36, 9 2s are 18, 19, 20, 21. So this becomes 216x square plus 3 cube is 9, 9 into 8, 9 is 72x plus 3 to the power 4 is 81. So this is the expansion of 2x plus 3 whole to the power 4. Now I hope you've understood how to do binomial expansion using a Pascal's triangle. In the next video, I'm going to talk about the binomial theorem. Thank you.